Welcome everyone. This presentation is about the data visualization using Python's two most important library called as Matplotlib and Seaborn. So think of it in this way, like data without visualization is like a story with no pictures. So we have numbers, rows, columns, but you can't see what the data is trying to tell you, right? So that's exactly what we are going to fix out in this module. So by the end of this submodule, you will be able to take the raw data and turn it into an useful, beautiful chart that can communicate the insight instantly. So let us move on through the six major topics. One is the foundation of Matplotlib, the different plot types and when to use each of the plots, the subplots for showing the multiple views, customizing the axes and legends, making out the annotation and saving the figures, and the Seaborn library for statistical visualization plus 3D plots. So let us dive into it. So now this slide shows you about the roadmap for the entire module 3. So let us quickly walk through what each module covers so that you can know exactly what the course is all about. So in the module 1, we are going to learn about the foundations of Matplotlib. So before you can draw anything, you need to understand what Matplot is, right? So how is the Matplotlib, how to install it, how its internal structure is, and how does it work. And module 2 is going to be the plot types. Module 3, the subplots and layouts. Module 4, customizing the axes and the legends. Module 5 is annotation and savings. Module 6 and 7 is about the Seaborn library, the higher level library which is built on the Matplotlib. And module 8 is the 3D visualization, 3D scatter plots for multidimensional data. So each module is built on the previous one. So follow the sequence for the best learning experience. So now let us dive into what is data visualization. So before we write a single line of code, let's answer the most important question. Why do we visualize data, right? The human brain is fundamentally a visual processing machine. So the researchers show that we process the visual information 60,000 times faster than the text. So it is like, let that be not 60 times and not 600 times, but it is 60,000 times the brain processes, right? If it is a visual information. So look at the statistics on this slide. The 90% of all the information which is sent to the brain is visual. And a well-defined chart will take just 3 seconds to understand. And the same information in the form of a table might take even 10 minutes or more than that to observe. So let us consider a real world example. Imagine that you have a data set of 10,000 sales transactions. So if you give a spreadsheet and you have to read every rows to find the pattern, but if I show you a line chart of sales over time, you will instantly see that how is the sales spike in December, how is the sales dip in January. That's insight that took just 3 seconds, not 10 minutes. So another classic example which I can give you is about the COVID pandemic, where every news channel is have used the line charts and bar charts to show the case count. So no one read the table of numbers, they watched just the charts. So that's the power of visualization. So as a data professionals, your job is not just to visualize your data, it is to communicate what the data says. And visualization is the most powerful communication tool. So remember that a picture is worth 1,000 words in data science, and a good chart is worth 1,000 rows. And we are about to build the foundation that everything else will rest on this. So we can think like learning the rules of the grammar before you write a story. So you should try to jump straight to complex plot, but without understanding the underlying structure like figures, axes, artists, you'll be constantly confused about why things look wrong and why your code does not work. So by the end of the topic, you will be able to understand how the matplot is, and this understanding would make every future plots easier for you to build and debug. So let's start from the very beginning. So this Matplotlib is the grandfather or the foundation of almost all Python data visualization. So let me give you the history. So in 2003, a neuroscientist named as John D. Hunter was analyzing the brain scan data. So he needed a plotting tool for Python, but he found nothing good existed. So he built one himself, modeling it after Matplot's plotting interface, which was popular in scientific computing, and he called it as Matplotlib. It is a MATLAB plus plot plus library. So it is called as Matplotlib. So today, Matplotlib is the most widely used Python plotting library with over 100 million downloads per year, and the open source with a BSc license, meaning it is completely free for any use, including commercial, maintained by hundreds of contributors worldwide. And this engine that runs underneath many other tools you will use that the last point might be crucial for you as a student to understand. So when you call like pandas underscore data frame dot plot off, and when you see Seaborn and when you see a scikit-learn, it draws you a confusion matrix. All of them are secretly calling out the library called as Matplotlib. So if you understand Matplotlib, then you understand the entire engine behind all the Python visualization. So this Matplotlib is to Python plotting what a engine is to a car, right? So other tools are just fancy like dashboards that you have in car, the steering wheel that you have, the GPS. But without the engine, so without a matplot, the Python cannot run, right? So the same way, without an engine, a car cannot run. So this Python has got a very powerful library called Matplotlib for its visualization. So now we know like what Matplot library is. Let's talk about why you should use it and specifically why it is worth learning even when newer tools exist. Right? So there are 6 key advantages. It is very mature and stable. So this library has been made like 20 plus years ago. It was developed and the bugs has been found and fixed. And you've got a very control over this Matplotlib library, like every single element on a chart, the thickness of the line, the color of the grid line, the font or the axis label, all this can be controlled. So nothing is hidden here. And this Matplotlib library has got a massive ecosystem. So think like Matplotlib as a platform, like you've got Seaborn, Pandas, all of them are built on the top of the Matplotlib. So learning Matplotlib means that you are learning the foundation of all of these. And it can be give you the very good quality images, like you can export the images as in SVG format for any resolution. Like scientists can use the Matplotlib library to generate the figures for the academic journals or papers, and even it is good enough for your projects. And your Matplotlib library code, it runs identically on Windows, Mac, Linux, and even inside a Jupyter notebook or in a terminal. So the same code, same output everywhere. So it is a cross-platform. It is independent. And it is a free and open source. So no software license is needed to use this library. So you can read the source code, modify it, you can contribute to it. And this is open source philosophy at work. So compare this to your proprietary tool like Tableau or Power BI. They are easier to start with, but you have to pay the license fee, and which everyone cannot afford. So this is the need for the use of Matplotlib library. And now let us move on to the features of this Matplotlib library. So think of it as a menu at a restaurant. So we won't cook all the dishes today, but it is important to know what is available, right? So let's highlight the key features. So this Matplotlib is possessing a feature called as versatility. So Matplotlib can produce almost any type of 2D chart You can imagine, say, a line chart, a scatter chart, a bar chart, a histogram, a box plot, a violent plot, a contour plot, heat map, all from one library. So this means that you don't need to install 5 different tools for 5 different charts. And the next important feature is customization. So as mentioned before, the total control, the colors, the marker shapes, the font size, all has been all can be customized. So everything is simple parameter. So with a simple hashing pattern, even you can make out a hashing pattern on the bars. And next is about the NumPy integration. So the Pathplots, the Python's math library, the Python's plot called NumPy, it can be used directly here along with the Matplotlib. And the backend are the engines that actually draw the pixels on the screen. So when you run a desktop, it uses a windowing backend. So when you are in a Jupyter notebook, it uses an inline backend. So this is the backend system. This is one of the main important feature. And using the funch animation, you can create animated visualization. Think of a chart where the line grows as the time passes. So it is useful for physics simulation or time series animation or even for presentation. And even you can use the style sheets with one line. You can use the ggplot. You can completely change the look of all your plots to match a specific aesthetic, like the slides can beautifully be made with the style sheet. So the code snippet on the right shows you like how simple the switching styles are. So this is about the features. So before we use a Matplotlib, let us see how to install it. So there are 3 ways of installing it. The method 1 is using pip, method 2 is using conda, and method 3 is using the virtual environment variable. So first, using pip, we should give the command pip install matplotlib. So this works in the Python version, which is either 3.8 or the newer one. And method 2 is by using conda. Conda install matplotlib. So if you're using Anaconda or Miniconda, the popular Python distribution for data science, you can use this conda instead of pip. The main advantage of Conda is that it handles out the non-Python dependencies automatically. And method 3 is about the virtual environment. So this is the cleanest and the most professional approach. So this virtual environment is an isolated Python installation. So this is a command, like you can give Python -m v environment. It is virtual environment env. So this will create an isolated environment called as env. And next, source env/bin/activate. This activates the virtual environment. And if you are using Windows, then you can use env/scripts/activate. And next, you can install your Matplotlib library, pip install Matplotlib, which installs the Matplotlib only in this environment. So why do we have to use the virtual environment is that imagine that you have a project A which requires the Matplotlib version of 3.1 and project B requiring the Matplotlib 3.8. So without virtual environments, these would conflict. So with virtual environments, each project has its own copy that is mainly recommended for the students. So if you are just learning, you can use method 1. When you start working out with real-time projects, you can switch on to method 3, creating out the Matplotlib in the virtual environment. So this is a professional habit that you will save a lot of, you can get rid of from a lot of problems. So now you have installed the Matplotlib library. Now how to confirm it, whether it actually worked or not. So this slide shows you a simple 3-step verification process. Step 1 is you have to open the Python shell or the Jupyter notebook cell. And now you can type out like import matplotlib. If there is no error that appears, the installation was successful. If you see the error like module not found error, the installation has failed or you are in a wrong environment. So you can check out once there is no error, you can check out for the Matplotlib library version. So matplotlib dot underscore version underscore. So it will give you the version that you have installed. So this confirms you like what is the exact version that you have installed, and then you can make a test plot. You can just import your matplotlib dot pyplot as plt, and now if you can just check out whether your plot appears or not. You can give plt dot plot 1 2 3 then comma 4 5 6, and if you give plot dot show off, it is going to show you the graph. So if the plot does not appear in the Jupyter, then you can add the matplotlib inline at the top of your notebook. So if there is backend error on the server, you can set the matplotlib.use of aggregate before importing the pyplot, and then you can use plot.save figure of method to save your file. So you can just confirm whether you have installed your Matplotlib library correctly or not. And now let us see about the Matplotlib architecture. So think of it like organizing a photography. Like a figure is the entire museum gallery, the space that contains everything, okay? And axes are the individual frames on the wall. Like each one is a complete self-contained chart. The artists are everything inside each frame, say a line or a color or a label or a tick. So figure means that it is the outermost container. So created with plot plt dot figure of method or plt dot subplot of method. So it controls the overall size, the figure size, the resolution, the DPI of the image, and the background color. So it can hold one chart or even lot of sub charts too. And next is about axis. So where actual plotting happens, right? So despite the name axis, it means a complete self-contained plot, a coordinate system, a title, a label, a tick mark, and the data. So one figure can contain even multiple axes. And next is about the artist. So everything you see is an artist. The line you plot in a line 2D is a 2D artist. The bar in a bar chart, you call it as patch artist. The title text is a text artist. And every artist has got a property, say color, visibility, and position that you can modify. So why does this matter is when you are debugging a plot that looks wrong, knowing this hierarchy would help you ask a right question. Is this a figure level problem or an axis level problem, or it is an artist level problem? So look at the diagram here. The outer box that you see is a figure, right? So this this outer box is a figure. And inside this you have got two axes side by side, right? So two axes side by side. So inside each axis are the data line, which you can call it as the artist. Now let's go deeper on the figure, the top level container. So the best analogy is a figure frame or a canvas. So before an artist starts a painting, they need a canvas, right? So in Matplotlib, the figure is that canvas. So how to create a figure? So you can create a figure by using the code like here fig is equal to plot dot figure of 10 comma 6, and I've given the DPI as 100, the face color as white. So this gives you a full control what is supposed to be the figure size. Figure size is given in inches here, not in pixel, and DPI is dots per inch. So this is the explicit way of creating out the figure. And implicit way is when you call the plot plt dot plot of method for the first time, what happens is the Matplotlib automatically creates a figure for you. So here it is convenient for the quick exploration. That code on the side will shows you the explicit here approach. So figure 10,6 means that it is 10 inches wide and 6 inches tall. So DPI is 100, which means that 100 pixel per inch. So the actual image would be what? 1000 into 600 pixel, right? So the face color is given as white, which sets a background color as white. So why does this DPI also matters when working out with the screen, which has got a higher resolution? Okay, so when you have a higher resolution, you can save even your picture for printing or for publication with 300 DPI. And if you have to give the subtitle for your figure, you can give fig dot subtitle. It adds a title to your entire figure. So above all the axes and not to a single plot. So it is useful when you have a multiple subplot and you wanted to give the subtitle for the entire figure. So creating a figure does not show anything on the screen. You will still need to add the axis and plot the data into it. Okay. So next, let us see about the component 2, which is the heart of the Matplotlib. So the common sources of confusion that every learner have is axis. You hear axis and then think, what is this x-axis and y-axis? Um, this in Matplotlib, this axis is indicated by the capital A, okay, A in caps, axis. So this means the entire plot, the coordinate system, the data, the label, the things, the titles, and everything. So think of axis as a plot canvas within a figure canvas. So if the figure is a gallery wall, then the axis is the individual painting which is hanging on that wall. So the most common way to create the figure and the axis at the same time is fig dot, that is, you can just look at this, it is fig comma axis is equal to plot dot subplot of, you can give the figure size 8,5. So this single line creates you the figure and one axis. The subplot of function will return a tuple of figure comma axis, and that we can unpack it into two variables. So one you have as ax, all your plot goes through it as ax dot plot of, if you have to make out a line chart. If you want to make out a scatter plot, you can give ax dot scatter of. Here, if you want a bar chart, you can give ax dot bar of. Histogram ax dot histof. Then if you want to set that title, you can give ax dot set underscore title of. If you want to give the axis label for x and y axis, ax dot set underscore x label of. Then if it is for y, ax dot set underscore y label of. So notice that the figure with one axis, you can call it as a single chart, and figure if you have a multiple axis, you can call it as a dashboard, or even you can call it as a comparison view. So this is about the axis. And now let us move on to the artist. So artist is a lower level in the Matplotlib hierarchy. So but they are literally everything that you can see here. So line 2D. So when you call ax dot plot of, it creates a line 2D object. So each line has a property like color, line width, line style, and the alpha. Patch is any filled shape. When you call ax dot bar of, then each bar is a rectangular patch. So when you call ax dot pi of, then each wedge is going to be the wedge patch. Text, every piece of text is a text artist. So it includes the title, the axis label, the tick labels, and everything. Next is about the tick. So tick is the smaller mark on the axis. So there are major ticks and minor ticks. So you can control their size, shapes, direction, and the frequency. Next is about the legend. So legend box created by ax.ax.legend of. It is itself an artist containing a smaller artist inside. Spine, the four border, that is the top, bottom, left and right of an axis, you call it as a spine artist. So you can make them visible or invisible, changing their color and moving their position. Next is about the axis label. So this axis title test, this text is its own specific artist type. And image, when you call ax.im show off, you can display the image or a heat map. It creates the axis image artist. So why should we know this is that the way that you customize anything in Matplotlib is by accessing its artist and changing its property. So if you want a thicker line, then get a line 2D artist and change the line width. So want no top border, then you have to get the spine artist and set the visible to false. So this artist is something which is very important. And this is a very important conceptual slide about the Matplotlib. Like it has got two API styles mainly. So the first API style is PyPlot versus the object-oriented one. So PyPlot is the older Matplot, this MATLAB style approach. So you call the function on the plot module, and the Matplotlib silently tracks the current figure and the current axis. So here you can see the Matplotlib status. So if you give plot plt.plot of 1 to 3 and plt.title of hello, and you can show this. So simple, it is very simple, it is compact, it is great for quick exploration. But still you can see here like the current style, that is object oriented style. So here the modern recommended approach it is. Here you can see that figure comma axis is plt.subplot of. You have included this line, so it is that like every call targets a specific axis. There is no ambiguity, there is no hidden state. So learners, it is highly recommended that you can write the functions and handle multiple figure protection always by using the object oriented style. And now let us see about the pie plot. So this is a convenient model that you can see it everywhere. So you can import the pie plot by import matplotlib.pyplot as PLT. So this PLT is universal, that every tutorial books or every Stack Overflow, everybody uses, but it is not a mandate that you have to use it. So this PyPlot is built around a state machine. It tracks out the current figure and the current axis internally. So every function that you call operates on that current figure or axis. And the common PyPlot function is the core plotting. It uses plot of or scatter off or bar of IM show off. And for the layout, you can use figure of function or subplot of function. To customize it, you can give X label, Y label, X tick or Y tick. So here the code on this slide shows you the typical PyPlot workflow. So you are going to create a new figure. You have to draw the data, say X comma Y, and you are adding the label, and you're going to display the result. So when does this PyPlot style become very problematic is that when you are working out in a loop that creates a 50 different figure, and when you have a function that builds a plot, the implicit state can cause one plot to bleed into another plot. So that is when the object-oriented style saves a day for you. Like you can feel comfortable to work on with the object-oriented programming style. And now let us quickly make out our very first Matplotlib plot. So let us break down every single line because even simple codes deserves full understanding. So line number 1. So import matplotlib.pyplot as PLT. This is the standard import. So PLT is the universal alias. And after this, all matplotlib functions are accessible as plt dot something of, right? Okay, so you can use this matplotlib library. You don't have to write down everywhere as matplotlib dot pyplot. You can instead you can use as plt dot, and you can mention the function. Okay, so line number 2 is I'm giving out x is equal to 1 2 3 4 5. So I'm creating a simple Python list for an x-axis value. So in a real project, this would be the dates or categories or numeric value from your data set. And line 3 is 2 4 6 8 and 10, the corresponding y-axis value. For every x value, there is exactly one y value, and they have the same number of elements, 5 each. So this is required. And you can see here, so this is x-axis and this is y-axis. So for 1 it is 2, and then for 2 it is 4. So you have got a linear line. And the next is method, which is a plt.plot of x comma y. So this tells the matplotlib to draw a line connecting the points, say 1 comma 2, 2 comma 4, 3 comma 6, 4 comma 8, and 5 comma 10. So the default style is the solid blue line. And if you wanted the Matplotlib library to show you the figure on the screen, so this plt dot show off will render the figure to the screen. So without this line in the Python script, you would see no output. So the output shows you a straight line, diagonal line from the bottom left to the top right, because y is exactly 2x of x. So you will have a linear relationship. So here the 5 lines is all it takes to go from raw data to a visual chart. And in the next slide, let us see like how do we add the label, color, styles, and multiple series. You can try changing the y values to 2 8 1 9 and 3 and observe how the chart changes. So the experimentation is one of the faster way to learn. So you can change the value of y and see how does the output change. So every well-designed chart has specific named components. So knowing these components is very important. So let us see it one by one. So first is the title. So the text at the top, which describes what the chart shows. So you can set with ax dot set underscore title of. It should be clear and very specific, like this is a chart which shows you the sales by quarter 2023. And next is about the y-axis label. So describes what is being measured vertically. So this is the y-axis. So you can see here the revenue is returned for the y as a y-axis label. You can even mention like the revenue is in the in terms of rupees or in dollars. And y-axis label, so this describes a horizontal dimension. Say it you can give out by ax dot set underscore x label of method. And tick mark is a small mark that on the axis that creates a scale, say as q1 q2 q3 and q4 on the x-axis, which is called as a tick mark, q1 q2 q3 and q4. And you can even make out the numbers on the y-axis as the tick mark. And the data series is the actual bar chart or the line or the points representing your data. So in a bar chart, these are the bars, and if it is a line, they'll have the line spikes. This is the 4 border line which is forming a box around you, around the plot area. So by default, all the 4 are visible. Often the designers, they might turn off the top and the right spikes for the clear look. And even you can make out the legend. So legend identifies that what each color or the series represent. Essentially, when you have a multiple data series created with, you can create with ax dot a legend of. After adding a legend, the parameter to each plot will be called. So remember that a chart without a title, the axis label, and the tick mark as incomplete. So these elements will transform the raw visuals into a communication tool. And now let us see like plot dot show off. It seems like simple, but understanding how it works prevents a lot of confusion. So when you call the plt.showOff method, it handles the figure to active backend for rendering. So the backend is a engine that turns your Matplotlib command into an actual pixel on the screen. So this the common backends and when each one is used is this TKAGG. So this TKAGG is a default for most of the desktop Python installation. So it opens a TK window showing your chart. So you have got lot other common backends, and you can see like when it can be used. And how does the backend affect your workflow is in a Jupyter notebook. You can run percentage matplotlib inline once, and the plot appear automatically after each cell, and you don't have to even need plot.showOff. So you can just run it and you can see your chart at the bottom. So this slide explains you like what is the conventions that every the Matplotlib user has to follow. Like PLT, as I have mentioned earlier, the four aliases shown here appear in most of the 100% of the data science code worldwide. So PLT for Matplotlib, like .pyplot. So every Matplotlib tutorial has got this, and NP for NumPy. NumPy is the foundation for numerical computing in Python. Almost all the data science code uses NumPy, and almost all of its import as NP. And PD is for Pandas. Pandas is a library for data tables, data frames. Generally, we call it as. So always it is imported as PD. And SNS for Seaborn. So Seaborn is a statistical visualization library which is built on the Matplotlib. So it is always imported as SNS. So here the code blocks at the bottom shows you the standard data science import block. So that appears at the top of almost every Jupyter notebook in the world, like import numpy as np, import numpy as pd, import matplotlib.pyplot as plt, import seaborn as SNS. So get in a habit of writing these four imports at the start of every notebook or a script. So many data science project templates include some by default. So following convention is not just politeness, it is a professionalism too. So it tells others that you understand how the real projects are being structured. And now let us have a look at the most fundamental Matplotlib function in detail, plt dot plot off. So this plt dot plot off, this you can consider it as 1, 2, 3, 4 as x comma y. So x comma y is going to be your data. It must be a sequence. It can be a list or a numpy array of equal length, where x goes on to the horizontal axis and y goes on to the vertical axis. And FMT is a format string. It is optional shorthand for style. It combines a color plus marker and the line style in one string. So example like G hyphen hyphen O. So it means that green color, you have to make out a dashed line and you are going to use a circle marker. Okay. And next you have got KW arguments. It's an additional keyword argument. Detailing, it is customizable. Say that you want the color to be as red, and you can mention the red as hash ff0000, or even you can mention it as small r. It controls the line color. You can make out the line style to be a solid or dash dot. You can make out the marker to be as circle, for O for circle, S for square, and even the triangle can be drawn. So the line width, the thickness of the line is generally by default it is 1.5, and you can change the thickness of the width of the line. You can set the label, you can give the marker size. For transparency, you can use alpha. So transparency from 0, if it is 0, it is invisible. If it is 1, then it is going to be fully opaque. So it is useful for overlapping the data. So here the example in the code like plt.plot of 1, 2, 3, 4 and 10, 20, 15 and 25. Here g dash dash 0. G dash dash, it is circle, it is indicated by O. The line width is 2, the marker size is 8, and the label is series A. So this draws a green dashed line with circle marker, the line thickness 2 and marker size of 8, and it is labeled as series A. So you can try changing the format string and the keyword arguments to see how the plot changes. So the experimentation is going to be your fastest teacher for you to teach. And these are some of the format string cheat sheets which you can refer to it. So if it is B, it's going to be blue, G for green, and C for Zion. And you can refer to the different line styles and the different markers out here. So mainly this O for circle, S for square, and it is higher than comparison is useful for triangle, the triangle up, the triangle down, it is paired with triangle up. So star for highlighting the special points, D for diamond, and plus to indicate for scientific or grid data. For scatter plot, you can use the cross symbol. So putting it all together, let us first analyze this the code altogether. Like we have imported the library, we have imported the Matplotlib library, and we have imported the NumPy. And now we have come across the method called as lens space. So this lens space creates the number. The lens space, the first indicates the start, 0 indicates the start, 10 indicates the stop, and number is 50. So it creates the 50 evenly spaced values between the start and the stop. So it creates 50 values from 0 to 10. So this is about the lens space, because NumPy is optimized for mathematical operations, and it creates and it works very seamlessly with the Matplotlib. And now for np dot sign of x. So np dot sign of, it computes the sign of each value in x, and this gives out the 50 y value following the sine wave pattern. And now let us make out the plot. So in the object oriented style, so you can create the figure fig comma x is equal to plt dot, it is plot dot subplot of figure size. I'm giving it as 8 comma 5, so which can give you an aspect ratio of 8:5. And now let us write down x dot plot of x comma y comma, and it is b, it is blue solid line that you want, and you want it as a circle marker. So you give as b hyphens o. So it gives you out the line width of 2. So the line width is going to be of thickness 2, and you can mention what is the label that you want. You can set the title as sine wave. You can set the x label, you can set the y-axis label, you can set the legend. So legend, it displays the legend using the label that we set in with um, x.plot of, and x.grid of a grid of method contains true comma alpha 0.3 as mentioned earlier. It adds a grid with 30% opacity. So every subtitle helps the reader to trace a value without being distracting. And the last one is plt.showOff, which will help you to show you the chart. So this is how the entire structure of making out a chart, and we have combined out all that we have learned into the single slide. So now a time for the real world example. So instead of making an abstract mathematical functions, we are now going to plot something meaningful. So let us have like the days Monday to Friday, and let us have the stock price on each and every day. So now we are going to use the Matplotlib dot plot of method to plot between the days and the price. I'm going to use a marker, a circle marker. I've given the color and the line width. So let us give the title for this. So it is going to print me the title and the y-axis and the x-axis label. So you can just explore this and you can see like what will be the output of this graph. So you can see here that this a real world connection, that this is exactly how how the financial analysis tool works. So like this pattern is always the same. You have to prepare x, you have to prepare y, you have to call the plot of method, you have to add the label, you have to format it, then you can use the show of method. So mastering this pattern will help you to visualize any data sets. So this slide covers out a very important practical concept for any beginner. Like every time that you call the plt.figure of method, right? So figure of method or subplot of method. So this Matplotlib allocates a memory for new figure object. Okay. So if you are in a loop that processes 100 of data sets and creates a plot for every one those figure objects, it will pile up in memory. So Matplotlib will warn you once that you have more than 20 open figures, or it will give you a warning like more than 20 figures have been opened. So figures created through PyPlot interface may not be a properly garbage collected. So this warning not just a is not just simply a script. You have to take it into concern, and you can close a figure when you have done with them. So you can close by using the function called plt.closeoff, which closes off the current figure. If you want to close all the open figures, you can give plt.closeoff all, which can close all the open figure, and plt.closeoff fig, which closes out the specific figure which is being mentioned here. So the best practice is to close a figure when it is not being used. So in scripts and loops, always close the figure after saving it. Then Jupyter Notebook during interactive exploration, it is less critical since since you usually have few figure only open at once. So this RC params is one of the Python's most powerful but underused feature. So let's set the global defaults that apply to every plot in your session. So what is this RC param is? It stands for runtime configuration parameter. So it is a dictionary that stores all of the Matplotlib's default settings, say the font size, the line width, the color, figure size, the grid setting, and the 100 more. Like, why do we have to use it? Is without the RC params, that you would have to set the line width as equal to 2, font sizes 14, etc. on every single plot. So when you use this RC params, you can set them once at the top of your notebook, and every plot automatically can use this setting. So this is a beautiful of using this RC param at every course. So in a professional workflow, the teams often have a shared RC parameter configuration, like at the top of every project notebook, ensuring a consistency styling across all the charts. Then you can go ahead with this global default setting. And if you want to set the individual RC param, the Matplotlib has built-in style sheet, which gives you a complete visual makeover in a single line, like plt.style. Use of ggplot. So that's it. It's one line changes the color, font, the background, the grid, and overall view of every subsequent plot. So this Default will give you like this is a classical look, the white background, the blue line, fine, but it is okay if you can, if you wanted a classical look, or you can go ahead with ggplot. It is inspired by the R programming people. It is a famous ggplot2 library. So gray background with white grid lines you can have. If it is Seaborn, based on Seaborn's default aesthetic view, like it has got a soft color palette with cleaner spine, and it is very professional looking. So these are some of the other uh, um, this dark background, the Bayesian method of hackers theme, classic. So these are some of the other built-in style sheets that you can have, which you can. So these are some of the beginner's pitfall, and you can fix it. So say that the plot does not appear, then you might have forgotten to include plt.showOff in script, so you can add the missing line. So if it is plot overlap, then you can add plot of multiple times without using plt.figureoff between them, so that the new figure can appear each line after the other. And if the memory keeps on growing, the figure should, which has been never been used, should be closed. So you can use, as mentioned earlier, like plt.close of figure after saving out your figure. So these are some of the different errors that as a beginner that you can face out. So you can fix it out very easily. So now the practice is how learning becomes skill, right? So this hands-on exercise can reinforce every thing from the entire lesson what we have learned. So the task, this is a task. I'll just tell you like what are you supposed to do under each step. So at step 1, you are supposed to create 100 evenly spaced x value from 0 to 2 into pi, and x is equal to like np dot line space of 0 comma, so 2 into np dot pi comma 100, because we have to create 100 evenly spaced, right? And why 100 points? So more points, smoother curve. So with 10 points the sine wave looks jagged, so like with 100 it looks smooth. And step 2, you can plot the cos of x and sine of x on the same axis. So you, if you have to plot two multiple plots on a single chart, just you can call ax dot plot of twice. So ax dot plot of, you can give like x comma np dot cos of x, then x dot plot of, then x comma np dot sine of x, right? So step 3 is you can add the title, axis, label, legend, and grid, and you can add up the grid. So you can even, you can stretch your goal, like you can use your style, like plt dot style dot use of ggplot, so it can create the figure. You can apply the style and see how the changes happen, and you can save your figure with 300 resolution, so with a .png format. And this is how you can practice well and reuse and try to find out the solution for the problem. You can try this experiment exercise 1.1. And excellent, you have completed now your foundation of Matplotlib. So let us do now a rapid recap of what you know now. Like you know how to install a Matplotlib library with pip, conda, and virtual environment, and we have seen the 3 architectural levels, like figure, what is architect, what is mean by axis, right? So then we have seen what are the different programming styles, like the pipeplot style and the object-oriented style, and we have you can go ahead like now converting the raw data to a label style. So that's a first plot that we have made, and you can even apply your style sheets. You can set the global parameter like RC parameters and use the a formatted string to format or customize your figure. You can debug it, debug the errors that you get, and you can fix it out. So this is all about your first submodule in data visualization. And next, we are going to see about the plot types and the use cases in module 2. So keep practicing with exercise 1.1. You will be able to make out more and more charts. Yes, in a fluent way. Thank you.